It looks like record. Okay, 10.2 is going to start talking about this idea of populations, samples, and what's this word? Okay, hypotheses. Okay, you start saying kind of like science, right? In science, have you guys done the plan, make a hypothesis, and then test it, and then come to a conclusion? Okay, so we're going to kind of talk about that a little bit. Guys, here's the deal. We're going to start looking at some sample populations, and this is really going to be pretty easy here. Okay, it says how can you test theoretical probability using sample data? Okay. So goals to talk about today. We want to distinguish between populations and what, kids? Samples, and then we're going to analyze a hypothesis. All right, pretty simple stuff. Okay, guys, what's population?
Amount of people in the area.
Okay, so give me an idea about the population of this school. What's the population of this school?
200 and.
Okay, so maybe instead of giving me a number, describe what you would say the population of this school is.
Total people that are in the school.
Everybody in the whole school, the whole population in the whole school, right? So population is going to be just that. It's a collection of how much of the data?
All.
Such as responses, measurements, or counts that you want information about. So if I said I'm going to go out and survey the population of UHS, who am I surveying?
Everybody.
Everybody. Okay, the population is the whole darn thing. Okay? Population's like a whole. It's everything. Okay? Then what the heck is a sample?
Like a portion of the whole.
Portion of the whole. This class would be considered a what? Is this class a sample of the population at UHS?
Yes.
So like here's UHS right here. Okay, the outside of the UHS, what might this represent right here?
Us.
Our room right there, right? Okay. It's a part of the population within the whole population, isn't it? So the best way to look at the samples is say, is that the whole population or part of the population? Well, it's part of it. Okay. So samples part or a subset of the population, and the population is going to be considered to be everybody. Okay. Now, you're going to hear some goofy words. Parameter. A parameter is a numerical description of a what? Parameters are based off of population, which is a what? So we base parameters off of the whole population. Okay. What's a statistic?
A numerical description of the sample characteristics.
Okay, so is a statistic talking about the whole population or part of the population? Part. Okay. All right, you know what a hypothesis is. It's a claim about a characteristic of a population, kind of like saying here, if this was a hypothesis about your population, the hypothesis was for this population here, you would say that you like candy, right? One hypothesis for this group would be you like candy, right? How would I test that?
Asking people if they like it.
Put a bunch of candy out and say, if you don't like it, don't take it. And everybody would take it, right? And then with that conclusion, or so I concluded that my hypothesis is probably true that you like candy. Okay. All right. So a hypothesis is just a claim. Are they always true? Are hypotheses always true? Like I say this. I might say this. I'm going to make a hypothesis. The Minnesota Twins will win the World Series this year.
That's false.
Well, it could be true, but we won't know until the end of the year, right?
At the end of the year.
The way it's going right now, the answer to that is definitely going to be
No.
a no. Okay. But it's going to be some kind of statement that you make, but you have to test it and prove it, right?
If you don't win over 90 games, you have a.
Because they may not win over 70 the way things are going. Okay. You guys have seen a Venn diagram before, right?
Yeah.
Diagram used to compare populations. I might have population A here, and I might have population B here. Where is population A and B overlapping at?
In the middle.
Okay, so we talk about overlapping information in here sometimes. Okay, there might be a set A and a set B. You guys have seen Venn diagrams before, right?
Yeah.
Okay.
Never.
All right, and then the last thing, proportion. You guys remember how to solve proportions? Cross, multiply, and. So for instance, I have x over 7 equals, I don't know, 3 over 21. How would you solve that? You have 3 times 7 divided by 21. What should the answer to that be? 1. Okay, so you remember that, okay? So the big idea to understand is this. We're talking about population and sample. Which one's the whole? And what's the subset, or the part? Okay, and we're talking parameters. Does parameters go with a population, or does parameters belong with a sample? I just remember P and P, parameter population, okay? And then the other part is statistic and SS and the PP. Can you remember that? Okay. All right, let's take a look at page 2 here, kids, and see what the heck we've got going on. Okay. Distinguishing between populations and sample. It says identify the population and the what? Then describe the sample. Okay. This first example says the owner of a dance studio asks 32 dancers what their favorite type of dance is, and 25 of them say hip hop. Okay, what's the population in this? Population is all 32, right? So what's the sample in this? The sample are the 25 people that like what? Guys, I don't know how to make this much more difficult. I can try to make it difficult, but is that pretty straightforward? Okay. A counselor at Easton Middle School pulled 225 student class schedules and found that 46 students have science. What's the population?
225.
225 students, right?
Is it warmer at dawn? And I was like, no, it hasn't hit 60. It's like 73 here.
Friends, what is the sample then?
46.
46 students where to describe that?
That has science.
Can I call it 46 science students then as the sample there? Because aren't 46 students part of the whole 225 schedules? Okay, so 46, what do you want to say here, kids? Science students? Can you differentiate between populations and samples?
Yes.
It's pretty straightforward, isn't it?
Very sure.
Gnarly. Okay. I know I'm going quickly, but are you on board with me right now? Questions to this point? Moving on. Distinguishing between parameters and what? Okay, parameters are going to deal with the whole population.
Finally.
Statistics are going to deal with the what? Okay, let's stop. For all teenagers in a certain town working jobs last summer, the average hourly wage was $6.95.
That's a week.
Okay, is the mean wage a parameter or a statistic? Explain the reasoning. Well, yeah. Okay, so how many of you guys are teenagers in here? How many of you guys have a summer job? Is there anybody in here that
I do
doesn't?
now. I do now. Well,
Is there anybody that doesn't have a summer job?
I might not.
Okay, that's
I
fine.
might not.
So here's the deal. Do all teenagers have a summer job?
No.
Because when I start this right here, for all teenagers, right, in a what?
Pound.
There's a certain number of teenagers in LaPorte City right now, right?
Correct.
Or let's just call it the Union Community School District. There's a certain, do all of those teenagers have a job?
No.
So when I start talking about numbers of the people that are teenagers with a job, is that a statistic or a parameter? Am I talking about all teenagers or some teenagers? If I'm talking about some teenagers, then it's part of a what? Which becomes a statistic. This would be a statistic because now if all teenagers had a job, then what would it be? Be a parameter, okay? I would say it's a statistic because not all teenagers in this town
No.
have what? Okay.
Shouldn't take some.
Okay, so the next one here says a survey of 912 men that were aged 50 to 60. So we're talking about a specific population of all men 50 to 60. How many are there? Okay. In Central America, found that the standard
4
deviation length of their
centimeters.
feet is about 4 centimeters. Is the standard deviation of the foot length a parameter or a statistic? This is an interesting one. This is an interesting one. What do you guys think?
Statistic.
Statistic? Why do you think it's statistic?
Because it's not all the same.
Because it's not what?
Not all the same.
Not all the same. Like, what do you mean, not all the same?
Like, some of their feet would be more than 4 inches almost.
Okay. What are we accounting for all of their feet?
Yeah.
Okay. Sam?
Well, I was gonna guess that there's not only 912 men ages 50 to 60 in Central.
So you're thinking in the whole country of Central America, there might be more than 912 men aged 50 to...
60?
Yeah.
Probably. Yeah, probably in Black Hawk County. What?
What is
Sam, is your house
Mexico?
I'm like not what is it? That was
for your address?
no, it definitely wouldn't be there.
Well,
So,
Google Maps says it's not
you
on.
guys are thinking statistic?
Really? I would put 4.
And your reasoning being?
This.
Let me look it up. I don't believe it.
I literally took a
There's not only 912 men.
Okay.
You don't know that?
Well, I mean, I
Don't know that for sure, do we?
know. but-
It's an area.
I bet I could Google up, though, and find out that there's probably a lot more than 912 men in Central America.
Maybe they took this.
Between ages 50 and 60.
Yeah, I bet so.
I don't think they were taking surveys then.
Back in the 900.
On the field.
900.
Okay, let me ask this question. Do you think they went around all of Central America and found every 50 to 60-year-old dude? Doubtful. I'm going to go statistic because
Nowadays. Maybe it's 912 actually identical.
okay, let's not go there. All right, statistic because this is
So many people.
only part of all men ages 50 to 60 in what country? Now, I'm going to go back to the last one. Okay. The first one kind of intrigues me now that you think about it that way. Kids, it says for all teenagers in a certain town working jobs last summer. So they're just kind of talking about the group of people that are doing what right there. They're kind of like saying my whole group is the people that are actually doing what? Working. We said this is probably a stat because not all teenagers in this town have jobs, but if you read it in a way that says, if you talk about the group just as working people, then that's all the people that are working, right? Could you almost argue parameter here, thinking that my whole population is just the people that are teenagers and work at the same time?
Yeah.
You could, couldn't you? So I think down below here, it's kind of subjective on some of these. I also think the way you think about this could be a parameter as well. Okay? If you think about it as not all teenagers in this town have jobs, then what's it become? But if you only look at the group that you're dealing with as all teenagers that have a job, and that's the only thing that's going to qualify them for that population, then could you argue parameter then? Do you guys see what I'm saying there? So could I say this would be a parameter if you're only talking about the kids that have what? So this first one, again, like I said, little subjective. It kind of depends on how you read that. I think you could argue either way on that. All right. Although I do think the second one is definitely what? A statistic. Okay. Statistic. Okay. Tough word to say sometimes. All right, my friends, you ready to roll? Questions so far? Pretty straightforward. Let's get to this last page. Guys, you roll a 6-sided die 5 times and do not get an even number. The probability of this happening is 1/2 to the 5th power, or 0.03125. So you suspect this die favors odd numbers. Well, not necessarily true, because what's the probability of rolling an odd?
50.
Okay, and what's the probability of rolling an even? Okay, so here's the deal. The die maker claims that the die does not favor odd numbers or even numbers. All right? It says, what should you conclude when you roll the die 50 times and get 23 odd numbers? Okay? Well, guys, I'm just going to tell you right here, the probability that you would roll an odd on any die, my friends, would equal what percent? 50%, right? Okay? Guys, in this example right here, they say you rolled the die 50 times, and how many times do you get an odd?
23.
Somebody take 23 and divide it by 50. Is that 0.46?
0.46.
Okay, so theoretically, if I roll a die 50 times, what percentage of the time should I get an odd? Theoretically. 50%. We rolled it 50 times. What percent did we get odds? Those percents fairly close, or are they pretty far off? They're fairly close. I think you're close enough. So you want to conclude that this die is fair or not fair? Based on these numbers, I think the die is what? Okay, let's take a look at what happened in the next trial. Okay? So again, the probability of rolling odds should theoretically be what when I roll a die? If I roll a die 100 times, theoretically I should get how many odds? If everything comes up equally, I should get 50, right? Theoretically, if stuff's supposed to come up equally, it should be 50%. But this time, my friends, we rolled the die how many times again? 50 times. How many times did we get odds this time? Experimentally, we got it 40 out of 50 times. My friends, 50% and 80%. Now, are they close, or are they getting pretty far off here? Kind of like, think about grading. If you had 80% and 50%, would they be pretty much the same grade?
Pretty much.
No. All right. What do you want to say about the fairness of this die now? Probably something's wrong here. Okay, it must be weighted on one side or something like that. But I would say in this scenario right here, the die is probably what? The die is not fair. Okay, kids, I'm going to send out a big ideas page for you, so you might want to get in there. I've got to write this up quick. Guys, I don't know what to tell you, but I think this is pretty straightforward and pretty much is what it is. Do you guys have any questions about this? In fact, I might gamble and say that might have been the easiest lesson we've had all year long. What do you think?
Yeah.
Yeah.